We're now looking at robust and secure programming. So one of the things that you can do to see if your programming is robust is to create a trace table so that you can see what is happening with the variables, spot any errors that might be going on. So we've got here figure 2 contains a subroutine that returns a value. Subroutine total out AB. Some stuff going on there. Complete the trace table below when the subroutine call total out 3, 4 is made. You may not need to use all of the rows in the table. So we're sending 3 and 4 into there. So when we first see C, what's stored inside it is 3 add 4, which is 7. And then A is 3, B is 4. So the next time we see it, we're saying A, so hold on, is this correct first? So A less than C, so A is less than C, that is true, so this bit of code is going to run. So A is now A plus 1, so that becomes 4, and B is B minus A. So 4 minus 4 is 0, and nothing's happened to C at this point. So now it runs again. So at this point we've got 4 is less than 7, so it does run, and then A has 1 added to it, and B has 5 taken away from it, so it's minus 5, and C stays the same. And the next iteration, so while A is less than 7, so it is still less than 7, so we add 1, and then we take away 11 now, because we're taking away A, which is taking away 6. And the next one, so while A is less than 7, so 6 is less than 7, so it's still true. So now A becomes 7, and we're taking away 7 from that, and C remains 7, and then the loop will end because this now becomes false because they are equal to each other. So the next question, a programmer mistakenly tries to shorten the subroutine in figure 2 by replacing the lines. So if we look at CA plus B while A is less than B, so it wants to replace this with the line while A is less than B, while A is less than A plus B. So A plus B would make 7. So while A is less than 7. So explain why this is a mistake. Right, so let's figure out why it's a mistake, because at the moment it looks like it's not a mistake, which makes me think this could be a logic error. So while A is less than 7, and then we've got A plus B, so while A is less than 7, so what happens next? I need to do a table. A, B, C. So if we have now A is less than C, so we've got 7 in there, we've got 3 in there, and we've got 4 in there, and we're saying while A is less than 7. So what will happen next time is it'll go A is A plus 1. It will go B is B take away A, so that'll be 0. And then it'll look at this again. So now it'll say while A is less than 4 plus 0. So it'll say YA, so 4, is less than 4. And then this will become false and it wouldn't work. So it's doing a logic error. And just to make that better, because it's a 2-mark question, not a 1-mark question. So explain why this is a mistake. It is a logic error and A and B will change where C would not. So that now gives me 2 points to my answer. We're now testing some data, or picking some test data to check the boundaries to see if it's working. So it says the pseudocode in figure 1 is written to make sure that the user enters a value within a given range. And we've got our pseudocode here. It says tick the set of test data that is the most appropriate to check that the code works as expected. So let's just see exactly what's happening here. So we're inputting something and we're saying while that input is less than or equal to 0. So that means 0 or any number less than that. Or we're saying it's more than or equal to 10. So we're saying 10 or any other number higher than 10. So this is the range that is in range, and then everything else is out of range. So if we wanted to test the boundaries, then we would want to make sure that we were definitely looking at 0 and 10 to make sure that it said not in range. But then we would want to check some of the normal data, so a number within that, just to check that it works the other way as well. So we're looking for 0 and 10, but we're also looking for some of the test data within that. So we've got 0 and 10 there, got 0 and 10 there. And it's saying the most appropriate. So you could do that one. But if we look down here, this checks both boundaries and some normal data within it. So that one is the most appropriate. Then we've got, why is the set of test data that you have chosen in question 3 likely to be enough to show that the code in figure 1 works as expected? So I'm going to put it tests the boundaries. And it's a 1 mark, so just simple, short, sharp answer.